In this video, I want to provide an introduction to propensity score matching. The idea with propensity score matching is that what you're trying to do is evaluate the average causal effect of some sort of treatment. But the problem with trying to do that is that there is an issue of selection bias, whereby those individuals who choose to be treated are different from those who aren't treated. So the idea here is that typically what we're doing when we're talking about doing propensity score matching is we have an issue whereby our sample who are treated, those who choose DI is equal to 1, and our sample who choose not to be treated by some given treatment, these two samples typically differ in terms of other factors other than the fact that they were treated. So there may be a whole list of different covariates within each of these two samples which are different. And hence, if we just compare a sort of difference in means between these two groups, the idea is that this is going to reflect both the average causal effect and some degree of selection bias. And the selection bias effect here reflects the fact that there are actually differences between these two groups in terms of other important covariates for determining some sort of outcome variable. So we've spoken about how it might in principle be possible to stratify our samples such that both of the samples had similar levels of these covariates, these xi here. But we've spoken about the problems in doing that. The main problem with doing that is the fact that if this xi, this list of other important covariates, is highly dimensional, in other words, if it reflects a number of different factors, then it becomes increasingly difficult to find matches between the treatment and the untreated group. Luckily, the propensity score theorem says that if the conditional independence assumption is true, then the values of the outcome variable, or the potential values of the outcome variable, y1i and y0i, let's say, are themselves conditionally independent of the treatment if we condition on the propensity score of an individual. And we've spoken about how the propensity score actually provides a way out of this issue of high dimensionality because the propensity score itself is a scalar function. It results in a scalar variable. And this scalar variable only takes on a value between 0 and 1. Hence, we could find individuals with similar levels of propensity scores and match on that criteria rather than having to search through a list of covariates and match across all of those different factors. In this video, I want to provide an introduction to how we actually go about doing propensity score matching and some of the intuition as to why it works. So the first step that we require when we do propensity score matching is obviously we need to estimate to some degree the propensity scores. So the idea is that we estimate propensity scores typically using either a logistic model, but some of the more recent papers have suggested that we do something called generalized boosted modeling, which is the idea of using decision trees. But both of these ideas result in the same sort of output. The idea is that we're trying to, for each individual in our sample, estimate the probability that they would have chosen to be treated given the list of covariates. After we've estimated propensity scores, the next step which we go through is the issue of matching. So the idea with matching is that we typically match across individuals. And across individuals, there are a number of different ways in which we can match. Some of the techniques fall under what is known as greedy matching. So the idea in all of this sort of matching, I should just say, is that what we're trying to do is we're trying to find individuals in our group that weren't treated which have a similar level of propensity score to those within the treatment group. So we're trying to match at an individual level. As I mentioned, one of the techniques for doing this is, or one of the class of techniques for doing this is known as greedy matching. Another one is known as optimal matching. But the premise behind both of these two procedures is exactly the same. What we're aiming to do is we're trying to find individuals within our group that aren't treated which have similar levels of propensity scores to those within the treatment group. After we've done the matching, typically what we do then is we do some sort of stratification. So the idea is that what we have is we have our treatment group, our group for which di is equal to 1, and we have our group for which di is equal to 0. And typically what we've done in the matching phase is we've actually thrown away a significant portion of our di group. So we might have thrown away these individuals and these individuals because of the fact that there aren't corresponding people within the treatment group who have similar levels of propensity scores. So the idea with stratification is that what we actually do is that we stratify both of these groups. So we create strata in our treatment group and corresponding strata in our untreated group. And the idea with these strata is that individuals within that particular strata have similar levels of propensity scores. So we might stratify according to groups sort of 0 to 0.2 in terms of propensity score, 0.2 to 0.4, etc. And we make up corresponding strata in both the treated and the untreated group. So after we've done stratification, the idea is what we then do is we can then compare the mean level of outcome variable within each of these two groups in the treated and the untreated case. So in this case where I've created 5 strata, for each of the strata in the treated and the untreated case, we could then calculate the difference in means of the outcome variable. And the idea from this is that we will then get an estimate of the average causal effect within each strata, so conditional on the propensity score within that particular strata. So just to reiterate that, the idea is that then what we do after stratification is we compare the mean of outcome variable. So after we've done that, and in this case we've got 5 strata, what we finally do is we typically take a weighted average of the particular strata mean differences across each of the different strata. And the idea is that this weighted average will actually then estimate the average causal effect across the entire sample. So the idea is that the average causal effect, or our estimate of the average causal effect, is the sum over all different strata, so that's sum over S, of the difference between y1s on average minus y0s on average, where y1s and y0s refer to the average level of y, the outcome variable, within the treated group, and y0s bar the average level of y within strata S of the untreated group. So just to summarise, in order to do propensity score matching, what we do is we first of all estimate the propensity scores, we then match across individuals in both the treated and the untreated group according to propensity scores. Then what we do is we do some sort of stratification and compare the means across these strata. And the idea is that by matching according to propensity score and by comparing strata which have similar levels of propensity score with each other in both the treated and the untreated case, the idea is that we will be then comparing apples with apples, and hence differences between the two groups likely reflect the average causal effect of the treatment rather than selection bias.